Alright, we are at section 2.8. This is going to be our last section before we take a test on this. I think I have two sections, so I've got A and B. Then we'll do a review and a quiz just on 2.8. That'll take us pretty much through this week, and I'll probably give you like a review for the test. So probably next week, early next week, before we go on the senior trip, we'll take a test on up to 2.8. So what was the last? It's like 2.6, 7, and 8, I believe, if I remember right. Okay, so here's 2.8. Here's the first part of 2.8. What we're going to do is we're going to deal with inequalities again, but we're going to do that tomorrow. Today we're just working with absolute value. All right, so we're going to solve equations, but this time we're going to use absolute value. Remember what absolute value is? For instance, if I said this, yep, two lines, you got a number in the middle, right in between those two lines. This is about as easy as it gets. Well, actually, next to as easy as it gets. If I have the absolute value of negative 5, what is the absolute value of negative 5? Just plain old positive 5. Okay? What is the absolute value? The absolute value basically is this. It's the distance, how far away a number is from 0. Okay, it's just the distance. It's how far away it is. Okay, it has nothing to do with the direction. So here's negative 5 right there. So if I asked you how far away from 0 is negative 5, you would just tell me it's 5 places, isn't it? So when you're asking for the absolute value, it's just saying how many places away from 0 is that particular number. Does that make any sense? Everybody with me? Okay? Everybody writing this down? Most of you are. There's still some that are not. You should be writing this down. So the absolute value of negative 5 is just plain old positive 5. Because we don't care, absolute value, we don't care about the sign, all right? We just care about how far away. So if I asked you, hey, let's walk 300 yards in that direction, would it matter what direction? You're still walking 300. There's no negative, I'm not going to say walk negative 300 yards, am I? I'm just going to say walk 300 yards, and you can walk in any direction. If I just said walk 5 feet, what would you do? You could walk 5 feet to the left. Jared, already? Go on now. I just got started. All right, wait till I get halfway through before you start falling asleep. So look, if I want to go to negative 5, how many places do I go? I just go 5 places away, don't I? Did I count right? 1, 2, 3, 4, 5. Yep. So what if I was positive? What if I was here at positive 5? It's still 5 places, isn't it? It doesn't matter if you went negative or if you went positive. So that's what the absolute value is telling you. Okay, it says how far away from this particular number is it from 0? Well, it's 5 places away, so it's just positive 5. So what if I said, what's the absolute value of positive 5? What would you say? Again, ask yourself that question. How many places away from 0 is positive 5? Well, it's 5 places away. Does that make sense? All right, yeah, pretty basic. What if we did this? What if I said, what if I asked you what the absolute value of this was? Now watch what we do. Okay, don't just make everything in here plus. Now in this actual situation, it actually would work if you did, but it's not always going to work, and I'll show you why. But we work what's in here first. Okay, so if I wanted to figure out what's in here, forget the absolute value for right now. Just work what's in there. So what's negative 2 minus 7? It's negative 9. Okay, so I do what's in the absolute value first, and then I can apply that absolute value to it. What's the absolute value of negative 9? It's positive 9. Okay, and some people do this. Don't do this. Okay, don't write this down. Some people say, oh, let's make that positive and that positive because everything in an absolute value is a positive. Now that actually does work, doesn't it? Because 2 plus 7 is 9, absolute value of 9 is 9. But what if you had something like this? What if you had 2 minus 7? Do we just make everything in here positive? No, because if I did, that would make that positive. 2 plus 7 is 9, but that's not the answer here, is it? What is it? It's the absolute value of what?
5.
Negative 5. And what's the absolute value of negative 5? It's positive 5. Make sense? All right. I don't even know if we have to do that kind of stuff with this. That was just a quick background of absolute value, just in case. Have we done absolute value in here this year? We did? Okay. I thought it sounded pretty familiar, okay, that I taught this year. I don't think I did that in geometry, but anyway, I just thought that's a good reminder on what absolute value actually is. Let's go a little bit different this time. All right, what we're going to do is this. I'm going to put a variable inside the absolute value, and I'm going to say that's equal to, I don't know, 3. All right. So let's think about this. What can x equal in order for this thing to be true? It can be positive 3, right? Because if I stuck a 3 in for there, what's the absolute value of positive 3? It's 3. Leslie, what'd you say? It could also be negative 3, couldn't it? All right, because watch this. If I stuck a negative 3 in for this x, what's the absolute value of negative 3? It's positive 3, isn't it? Does that make sense? All right, so I could put a positive 3 in for this, and it'll work. I could put a negative 3 in for this, and it'll work. Everybody with me? That's really important. I don't think you see the significance of how important that is right now, but you will a little bit later. Okay, so write it down. Jot this stuff down in your notes because this is really, really important. What if I did this? What if I did x plus 1 in absolute value equals, 5? What if I did that? Just in our head, what do you think an answer? X plus 1. What can I add 1 to it? 2. Okay, I could put a 4, right? So x would be equal to 4. Would you agree? All right, because 4 plus 1 is 5, the absolute value of 5. Would you agree? Okay, what else could I put in here? What's that?
-6.
You all right?
Tired.
Is that what it is? Okay. All right, so you could put a -6 in here as well, couldn't you? Why is that? Because if I took the absolute value of -5, it's going to be 5. So what makes this thing a -5? A -6 would. So x could also equal -6. Plug them back in and see. 4 plus 1 is 5. Absolute value of 5 is 5. Excuse me. What if you put a -6 in there? -6 plus 1 is -5. What's the absolute value of -5? It's positive 5. So both of these actually work, don't they? I'm going to push this. I'll tell you what. Let's just erase it. You remember what the numbers are, right? What I'm going to do is this. I'm going to show you a little way, a little method, because sometimes it gets a little bit more complicated. Sometimes you can't just look at it and decide what's supposed to go in there. On this one, I made it pretty easy, so you can just kind of figure it out in your head. But watch what we could do. And there's a little rule. It's you don't have your book with you probably, but there's a rule in the book. It's called the properties of absolute value, and this is one of the properties of absolute value. It says this. Let's just keep this all together, okay? It says this: if I have an absolute value, and it goes by this thing right here, okay, this thing is the reason for our property. So look what I did. If I wanted to solve for x, if it's in absolute value, I did two things, didn't I? I took that x and I just set it equal to whatever that number is on the right, didn't I? X equals 3. And then what did I do? I took that x and I set it equal to what? The negative. So I actually took that x and set it equal to a positive 3 and to a negative 3. So let's use that little method right there and apply it to this thing. So what do you think I'm going to do here? I'm going to take that x plus 1 outside of the absolute value, and I'm going to set it equal to what? Just regular positive 5, okay? So it looks just like this did, except it doesn't have absolute value symbols. Everybody with me on that? Okay. Now, what else did we do, though? We took that thing inside the absolute value and we set it equal to the negative of this, correct? So let's do the same thing here. So we actually have, and I do this sometimes, I'll put a 1 and a 2, because we actually write down two different equations. That's our first one. Our first one looks just like this, except we just get rid of the absolute value symbols. The other one, we get rid of the absolute value, but we set it equal to the opposite of this, right? And that would be a -5. And that's the second equation. So look, we get two answers for this, don't we? And we're going to get two answers for this as well. So I write down two equations. You don't have to write the 1 and the 2. Sometimes I just think it's helpful just to get an idea of what to do. So what did we do? We took this, we set it equal. We basically just rewrote it exactly the way it was. We just got rid of the absolute value. And then we went over here. We got rid of the absolute value, but instead of just setting it equal to 5, we set it equal to the negative, all right, to the opposite of that. All right? And now we can just go ahead and solve. And watch what happens. We get the same answers that we came up with kind of in our head before, didn't we? Subtract 1 from both sides, so x is 4. So that's one answer. And then subtract 1 from both sides, and x is -6. Isn't that exactly what we got earlier? But that's the method on how we do this. Okay, we set up two different equations. The first one looks just like this. We just get rid of the absolute value. The second one kind of looks like it, but we get rid of the absolute value and we change the sign of the right side. Does it make sense on why we do that? It all comes back to this thing right here. Look, We got rid of the absolute values and just set it equal to that number. Then we got rid of the absolute values and set it equal to the negative of that number. All right, that made sense to you, didn't it? We do the same exact thing if we have more stuff inside of the absolute value. All right, let's do one just a little bit more complicated. By the way, what if I did this before I get to the next example? What if I said that? What's my answer for x? What's my solution for x? Why is it nothing, Leslie? It's a good answer.
Always.
That's right, because she said the absolute value of something can never be a negative. It always has to be positive. So is there any number I could put in for this at all to get a negative anything? No, there's nothing. Okay? Doesn't matter if I stick a -3 in here, because what's the absolute value do to it? Makes it positive. There's no way I can get a -3. So this does not exist. All right? So it might throw you through a loop every once in a while. Okay? So remember that, though. That's pretty important. I hope you wrote that down. All right, let's go to a different color. I'm tired of writing just in white. All right, let's do this example, and I'll give you a second to work on it yourself. See if you can do this yourself. Okay, I'll give you a second to work on that. Okay, remember, you have two equations, don't you? Here's the first one. I always like to put a 1 and a 2 here, just so I can remember to put two equations. All right, the first one looks just like this. We just get rid of the absolute value. All right, so you just write it like this. I write the equations down first before I start solving for them. Okay, the second equation, we get rid of the absolute value, just like we did earlier, but we change one thing. What do we change? The sign on where? On the right side. On the right side, right. So this is going to be a -12. And now we just do regular old math, and we just solve for m. All right? So we subtract 5 from both sides. -3m equals 7. Divide by -3, and there's your answer. M equals -7/3. So that's one answer. But you can't just leave it there. You got to do the second one. If this is all you do and you just circle it and turn it in for a quiz or a test problem, I have to mark it wrong because you haven't given me all the solutions. All right, this one right here. Let's do the same math. Subtract 5 from both sides. Bring this down. That's -17. Divide by -3. And m is, now negative over negative. A lot of you guys are still leaving negative over negative. Don't leave it like that. Make it 17/3. It's positive. So those are your two answers. You got both of those answers right. Okay, good. Pretty simple, isn't it? Yeah. Okay, as long as you know the routine on what to do. It's nice to know why we did it too, right? The very first thing we talked about today was why that's true. But you know, even if you don't know why you do this, just do it. All right, write down the two equations, and on and on. All right, let's do another one. I'll give you a little hint on the other one, but I'll let you try that one as well. Let's see. This one looks a little bit different, but you're still going to do the same thing. Okay? Look at this. What's different about this compared to what we did before? Yeah, it's two absolute values. The absolute value on the right side. But we have a rule. And if you look on the rule on, and again, you probably don't have your book with you, but it's on page 149. It'll show you this rule right here. But this is what we do. We basically do it the same way as we just did the other one. I'll set it up for you and let you solve for m yourself, okay, and give you a little practice. Might help you keep awake. So first thing we do, I'll put a 1 here because this is our first equation. We go 4m minus 3 equals m plus 6. So we write it exactly the way it looks up here. What do we do, though? What's the only thing different? We just get rid of what?
Absolute.
The absolute value, right. Okay, so that's what we do right there. And then we'll solve for m in a second. Then our second thing, what do you think? What do you think the left side's going to be? Just 4m minus 3, right? But what do you think we're going to change here? Put it. That's right, very good. I like to hear that. It's a negative. It's not just -m plus 6, is it? It's negative in parentheses what? M plus 6, because we have to take the opposite of the whole entire right side. So if I have more stuff on the right side, I have to distribute that negative, don't I? All right? I'll give you a minute. Work on that. Solve for m. All right, that should be enough time. Let's do this. We got to solve for m, so we subtract an. Oops, that's weird looking. That's all right. Subtract an m from both sides, and since we got an m on the left side, I'll take this number and put it on the right side. So that's 3m That cancels. That cancels. That's 9. Divide by 3. M is 3. Alright, that was easy enough. Let's do this one. Again, this is really the only semi-difficult part of this at all. Okay, and I don't even think I would consider it difficult. Distribute the negative through here, so it's negative m minus 6. And now you just solve it just like you did over there. Alright, so it's plus m. Add a 3 to both sides. And let's see what we get. 4m plus m is 5m. That cancels. That cancels. Negative 6 plus 3 is negative 3. Divide by 5, and it's negative 3/5. And that's all there is to it. Not that big of a deal, is it? Seems very Algebra 1-ish kind of stuff, doesn't it? Yeah, not hard at all. And you probably did this in Algebra 1, to tell you the truth, with absolute values and solving for x. All right, well, that's all I got for you today. Tomorrow, we are going to. What do you think? What do you think the difference is? What's that? No, we're not going to graph it. Lucky for you, at least today, we're not going to graph it. I think we have another chapter where we will graph this stuff, okay, but not in this chapter. What do we have so far? Yeah, that's right. So we had equals, right? And so just like we did not too long ago, we changed to inequalities, and we're going to change to inequalities. And it's really not that much more difficult. There's one little extra thing you have to do, and I probably could technically teach it today, but I do have to split up between A and B. So the A is the equal stuff, and the B will be the inequality. All right? So your worksheet today is 2.8a.